Welcome back to our Python Basics series. Today, we're talking about imports. These make your life super easy when you're programming, so let's take a look at them. Let's start by explaining what an import is. Importing allows Python code in one module to gain access to code in another module. This is important because it makes the programming process simple and more effective. This is known as modular programming. It is a method of breaking large coding tasks into smaller and more manageable subtasks. To do this, Python has many modules, packages, libraries, and frameworks. The power of Python being open source allows you to have great tools at your fingertips that you can easily install and use. A module is related code saved in a file. When you are working on a large project, you may have a lot of modules that are difficult to manage. Packages are directories of a collection of modules. A common package is the random package. That brings us to libraries, which is a term used when referring to reusable code. For example, a Python library may contain a collection of related modules and packages. A common example of a package and library that a lot of people use is Pandas, and that's for working with data. Finally, frameworks are a collection of modules and packages that are more complex than libraries. Frameworks can contain the basic flow and architecture of an application. An example of this is Flask or Django, which are both Python web frameworks. As you get more comfortable with programming, I would recommend exploring the ones out there and playing around with them. Mostly everything is well documented, and there's support on the internet for additional help, making getting started super simple. If you remember back to the first episode of the series, I discussed Anaconda. This is a tool that I chose to manage my virtual environments. The purpose is to simplify package management as well as deployment. We essentially create a new Python environment for the Python interpreter so that we can install libraries and isolate them from other environments. An example of how this could be useful: if you developed an application in Python, you would want a virtual environment. You can include all of your dependencies within this environment. Now, if you were to go and deploy your application to a Linux instance in the cloud, you have an environment that you can easily match to ensure your application can run. Additionally, you can share your environment to others so they can match theirs to yours. In a future series on the channel, we'll go deeper into environment management. Looking at my Visual Studio Code, you may notice that my terminal says YouTube. This is my virtual environment for this channel. Since I'm using Anaconda, we can type in conda end list, and this will give us a list of all of our virtual environments. As you can see, I have quite a few, but the star indicates that the YouTube one is active. Now if we come up here and we type in conda list, we can see what I have installed within my environment. Currently, my YouTube virtual environment has no packages installed. If we wanted to use a package such as Pandas, we would have to install it. Once it was installed in our environment, we'd have access to it. The thing that I like about Anaconda is that it conducts dependency checks. This ensures that a package has what it needs and everything in the environment plays well together. Another option is using pip. Pip is another package management system used to install and manage software packages. Within Visual Studio Code, you can manage packages and install them through a graphical user interface or GUI. For the purposes of this series, we're going to stick with Anaconda. Let's start by looking at installing a Python package. We'll install Pandas. As a reminder, our virtual environment is empty at the moment. Let's clear our terminal and install Pandas. To do this, we just say conda install pandas. Optionally, if you know what version you want, you can also specify that in the command before running it, but in our case, we'll just install Pandas. Here you can see that it started downloading it, and it's asking me if we want to proceed, where I'll just type in Y and hit enter. As you can see, it let me know that it successfully installed Pandas. Now if we clear our terminal, we can type in conda list again and see what's in our environment. As you can see, it installed everything that Pandas needs, including Pandas itself, which is version 1.3.5. For now, let's go ahead and hide all of this. Now we're ready to import items within our code. We're going to look at a few examples of various ways of doing this. As this is most likely new to most people watching this video, make sure you check the description down below for additional practice and material. For the sake of this example, let's keep it simple and just work with the datetime module. For those who don't know, the datetime module just applies classes to work with date and time. We'll discuss modules and packages in future series, but if you're interested in learning more about datetime, there's documentation as well as a ton of help online. Let's start with the most basic import. We can say import datetime. Doing this now grants us access to anything within the datetime module. For example, let's come down and create a variable called now and set that equal to datetime.datetime.now. If we came down and we printed now, you'll see that when we run it, it prints out the current date time. It may get tiring typing in datetime.datetime.function every single time you wanted to utilize this. What you're able to do is specify within your import and say as, and you could shorten it to DT. If we look at line 3, you'll notice that it no longer likes the first date time. That's because we're not just importing datetime as a module now. Now we're specifying it as DT. To correct this, all we have to do is come down here and replace the datetime with DT. Now we have now equals dt.datetime.now. If we were to run this, you'll see that it does the exact same thing, but now instead of typing out datetime, we just have to say DT. Right now what we're doing is we're specifying the module and then the function that we're using, and then we're calling it. In our specific example, we're saying DT as in look at the datetime module and then get datetime.now, and then set that equal to the variable now. Now, if we know that the datetime function is the only function that we need from the module, we can make this even simpler. For example, if we came in our code, we could add a new one and use from. The syntax for this is we say from datetime, datetime being the module that we're referencing, import the function we want, which is datetime. We no longer need this line. Once again, in line 3, you'll see that it doesn't like the DT. That's due to the fact that we're saying from the datetime module, import the function datetime. In line 3, we no longer need anything besides datetime.now. If we were to run this now, you'll see that it still works. We can combine this with the as, and we could say as DT. Now we're saying from datetime, import datetime as DT. In line 3, you'll see it doesn't like the datetime because it doesn't know what it's referencing. So now if we switch this to DT, that's referring to the datetime function of the datetime module. If we ran this, you'll see that it still does the exact same thing we would expect. And then finally, the last one that we're going to talk about is star. This isn't something that I'd recommend doing just because it's very inefficient, but it's still good knowledge to have. To do this, we'll come up and say from datetime import, and we'll say star instead of putting in functions. Since we imported star, we have access to every single function within datetime. So down in line 3, we can go back to the datetime function, and it knows exactly what we're talking about because we imported it from the datetime module as star. When we run this, you'll see that it works. Once again, this is good knowledge to have, but I would not recommend using it. If you knew you needed multiple functions from a module, you can just import them and separate them by commas. For example, we could replace the star and we could say datetime and we could say time delta, which is another function within datetime. This import statement now specifies the two functions we need instead of inefficiently importing every single one. Within your code, it's normally best practice to put your imports at the very top. One last thing to note is you can have multiple lines of imports. For example, right now we're importing datetime and time delta from the datetime module. If we additionally wanted to import the random package, we could come down and say import random. Now all of these tools and packages are available for us to use within our code. That about wraps up imports. If there were things that didn't make sense, make sure you review the documents that I put in the description. When you have limited programming exposure, this is a harder concept to grasp. As you continue using imports, they'll just become easier and easier. In our next episode, we're going to be talking about functions and methods. With the information you learn in the episode, it'll hopefully help connect some dots and make it easier to work with imports. Thank you for watching, and please like, comment, share, and subscribe.